The Moon was formed about 4.5 billion years ago, after a planetary body collided with a young Earth. Debris was sent flying into space and gathered together to form a fiery moon. The Moon then cooled after some time and was hit by an asteroid, creating the South Pole Aitken Basin, roughly 4.3 billion years ago. After a few million years, the Moon was then bombarded by asteroids, creating volcanic eruptions. These eruptions then cooled and created spots on the Moon that resembled Earth's seas, which we called mare. The Moon was once again pelted by comets and asteroids, forming many craters.
To nearly everyone, the Moon appears to be a sterile, gray, unchanging world. But while the Moon has remained largely unchanged during human history, our own understanding of it has evolved dramatically. Thanks to new observations, we now have not only unprecedented views of its surface, but a whole new tour of the Moon that shows how both it and other rocky planets in our solar system have been shaped over billions of years. We'll start with one of the largest impacts, Oriental Basin, a feature that's as wide as the distance from New York City to Cincinnati. Using new elevation measurements, we can clearly see the effects of what is likely the last giant impact event in lunar history, with its outer mountain rings rising many kilometers above the lowest points inside the crater. The interiors of some craters in the Moon's polar regions, like Shackleton, haven't seen sunlight in over 2 billion years. However, new measurements have created our best yet maps of these types of craters, allowing us to see deep into the shadows of this surprisingly young-looking impact crater in the south that's more than twice as deep as the Grand Canyon. Some impacts are invisible for other reasons. Although the ancient South Pole Aitken Basin is difficult to see from orbit because it is so large, new LRO topography maps reveal the largest impact basin in the Earth-Moon system, measuring several kilometers in depth and around 2,500 kilometers in diameter. Only the Hellas Basin on Mars rivals it in size.
Our Moon is made of rock. It has craters, mountains, and valleys. The gravity on the Moon is about 1/6 that of the Earth's, and it takes the Moon roughly 28 days for it to revolve around the Earth. As the Moon revolves around the Earth revolves around the Sun. The revolution of the Moon around the Earth is what changes its appearance as it reflects the light from the Sun. This is called the lunar cycle. The Moon is responsible for the tides we see on Earth. Tides are the regular rise and fall of the ocean's surface. There are 2 in the morning, a low tide and a high tide, and 2 in the evening.
As we continue to study the Moon, our understanding of it improves, giving us new insights not only into how it has evolved over time, but also how other rocky planets in our solar system have come to look the way they do. With new missions, new instruments, and new technologies, we will continue to improve our knowledge of the Moon and better understand the history of our solar system.